We apply force at every moment in our daily life. Whether in weightlifting, exercising in the gym, canoeing, running, or in pushing a luggage trolley, we have to exert force. Stretch a rubber band with force and the rubber band changes its shape. Release the rubber band and it resumes its original shape. Press a piece of plasticine against a tabletop and the plasticine becomes flat. Kick a football hard. When the football hits an object, the force changes the shape of the ball. From those examples, we can conclude that when we exert force on an object, the force can change the shape of the object. For some objects, such as rubber bands, springs, sponges, and rubber balls, their shapes change when they're subject to force. But when the forces are released, their shapes recover quickly. For some other objects, such as plasticine, sheets of paper, pieces of metal wire, and wooden sticks, their shapes change permanently when they're subject to force. They may also be deformed, flattened, or even snap. A trolley is suspended on a linear air track. The trolley is stationary. Just push the trolley slightly and it glides forward. Every cyclist here is highly concentrated. When they hear the starting signal, they have to pedal hard to accelerate the bicycle from rest. If they wish to further accelerate, they have to exert force continuously on the pedals. If we exert force on the gliding trolley in a direction opposite to that of its movement, the trolley stops moving. If a cyclist wishes to decelerate, he has to hold the brake handle tight to activate the brake and use force to decelerate or stop the bicycle. Vehicles involved in highway accidents have usually been moving at a great speed. The great impact created upon colliding with obstacles along the road reduces the speed of the vehicles or even stops them. The impact also changes the shapes of the vehicles. Those examples show that force can change the speed of motion of objects. Forces can make a stationary object accelerate, change the speed of a moving object, or stop a moving object. When connected by a cotton thread to a pivot, a toy plane can move in a horizontal circle. As the plane turns continuously, its direction changes every moment. The fact that the plane can turn around is attributable to the force exerted by the cotton thread on the toy plane. Two balls rolling speedily towards each other collide and rebound in opposite directions. These two examples show that force can change the direction of motion of objects. There is a trolley on the table. Pull it and the trolley accelerates from a resting position. We need a Newton balance to measure the force used to pull the trolley. The unit of force is Newton and the symbol is N. When we pull the Newton balance, the pointer on the balance shows the magnitude of the force. Connect the Newton balance to a trolley. When we pull the Newton balance with force, the trolley also moves. The readings on the Newton balance show the force of pulling the trolley. Use a golf club to hit a golf ball and the small ball is driven onto the lawn far away. A golf ball accelerates to great speed within a very short time. The strength of the force exerted by the club on the golf ball is several thousand newtons. The force used to kick a football is about several hundred newtons. The force exerted by a private car when out of control and colliding into obstacles can be as great as several tens of thousands of newtons. Mutual force is exerted when objects are in contact, but some forces can be exerted when objects are at a distance. Throw up a ball and it falls back to the ground. Why doesn't a ball go out into space? When an apple on the tree ripens, it falls to the ground instead of going towards the sky. When a small ball slips off a table, why is it that it falls in a parabolic trajectory? The Earth revolves around the Sun day after day, yet there isn't any connection between the Earth and the Sun. In its elliptical orbit, the Earth changes speed and direction at different positions. The force of an object which acts on another object at a distance by virtue of its mass is known as gravity. All objects on Earth are subject to the gravity of the Earth. In other words, they're within the gravitational field of the Earth. Therefore, the movement of objects is affected by the gravity of the Earth. Put two circular magnetic rings over plastic beads. Push one of the magnets slightly. The two magnets move away from each other before they come in contact. Place two circular magnetic rings around an aluminium rod. The magnet above seems to be able to resist gravity and suspend itself in the air. This is another type of force acting at a distance. This is known as magnetic force. Pivot a magnetic needle in a stand. When the magnetic needle stops swinging, it always points to the south and the north of the Earth. The magnetic needle points to the north and the south directions under the action of the magnetic field of the Earth.